All right, so this week we're going to be going over basic input and output, as well as files and folders. So again, this week, Gaurav very kindly created the slides in the assignment. I think he's doing a great job of these, and I really like his approach to creating these slides. Especially this week, there's some stuff here that I think is like really helpful for that he added for comparative purposes between different operations that you can do on files and folders. But if anyone has any feedback on the assignments or slides that Gaurav's creating compared to the ones that I created, please let me know what you like from each and what you dislike from each, because I'd really love to combine the approaches that Gaurav is taking with the approaches that I had been taking in order to make the most effective slides and assignments for all of you. So that being said, this week we're covering basic input and output, as well as files and folders. Let's dive right in. There's a lot to cover. All right, so input and output, or I/O. So you'll often see in computer science, you'll see this I/O that stands for input and output, and you'll just hear it often referred to as I/O. There are times where I'll refer to it as I/O throughout this PowerPoint, just because it's a lot faster to say than input and output. Yeah, so just keep in mind, anytime you hear I/O in the technology space, they're referring to input and output. So inputs are ways to accept information from the user, whereas the output is to provide the information back to the user. Inputs and outputs both could be via the command line, user interfaces, or via files. So remember the print function that we've been using throughout the class so far? Well, this is a classic example of output to the console. So you've already been using output, the O part of I/O, and then we're going to learn more about input here. I know some of you in your assignments already have been using the basic user input, but yeah, you already know output, the most basic output there is, and that's just printing to the console. So classic example of output right here. So as we've seen before in some assignments, some of the ones that I've demonstrated as like a very exceptional and above and beyond way of approaching the assignment, we can use the input function to accept input from users. So inputs can be accepted from users using the input function in Python. So the input function stops the execution of the code and gives the control of the program to the user. And it's really like pausing the execution. It doesn't completely terminate it, it just temporarily stops it. And then the control is given to the user, and then the user must respond in order for the program to proceed. So the user is prompted to enter the data using their keyboard. And once the user enters the data and clicks enter, because enter is what signifies to the input function that the user is done inputting something, the control returns to the program, and the function input returns to the entered data in the form of a string. So this is very important to remember. No matter what you enter here, it's going to be a string. So, and then this can be processed further or displayed back to the user. So something you should always do whenever you're using the input function is you always want to store the value returned from the input function into a variable. So in here, we're using the input function, and within the input function, this is the prompt that you give the user. So this is basically kind of a hint that tells the user, what are you looking for here? And in this case, we're saying enter the number. Oops, I'm sorry, I didn't mean to click right there. So in here, we're saying enter the number. So basically, we're indicating to the user we want a number. And then once that input is received from the user, that'll be stored into the variable user input. And then in this particular program, we're printing the user input. So we have our input operation and then our output operation here. And this is the most basic I/O you'll see in Python. So when we run this program, it first asks the user, it says enter the number, and it basically prints out exactly what we have in this input, in the input parameter here. And then when the user enters 50, then clicks enter on their keyboard, it accepts 50 as user input, and then we just print that right back out to the console here. This is a super, super simple example of using I/O in Python. So the input function always treats the input as a string. It's worth mentioning twice because this is something that's very important to recognize. Because if you are wanting a number that you're then going to go add to something else, we're going to need to cast that to an integer or a float or whatever type of number we need. But we just need to make sure that you always know anything entered as user input is always going to be entered as a string. And then if you need to change that data type down the line, you certainly can. Something that's useful to know about for data typing is the isInstance function. So the isInstance function is a Python function that checks the data type in argument 1 with argument 2 and returns the Boolean result. So, and then you can also use the type function to find the arg2 class type. So for argument, so this is for the argument 2 here. So what we see in here is we have user input, and then input again, and in input we're saying enter the number. It's basically the same thing we saw in the last slide, and then we are printing out is user input data of data type a string, and then we're using the isInstance function, and then the first argument is the user input that we want to compare to a particular data type, and then the second argument is the data type we want to compare it to. So in this case, we're saying you can kind of read it as like is user input an instance of a string or a star. In case you weren't sure what the abbreviation is, the class abbreviation is for this, for star, then we can use the type. So here we're printing out the type of the data, and then we're using the type function and then passing user input there, and it'll output the class type that that data type is. So in this particular case, we run the program. It outputs enter the number. The user enters 50, clicks, and then clicks the enter key. And then we print out is user input data type a string. Since we're doing the isInstance function, it's checking is user input an instance of a string. That's true, because anytime you enter anything in the input here, it's a string. So even though they entered the number 50, and we can all recognize that that's a number, Python will data type it as a string. So so then when we do this isInstance, it's saying like, yes, user input is an instance of a string, and we see the true here. If we said int here, because we wanted to check if it's an int, this would output false, because user input entered is always a string. It's never a number or anything like that. And then in case we weren't sure what the type was and we wanted to figure out what the type class is, we said we can say type of data, and then we just do type user input, and that outputs class str, or which stands for string. So if we had done type and then just the number 1 without any quotes around it, anything, so that's an integer, it would say class int. If we did 1.0, it would say class float. So whatever's in the quotes here, that's going to kind of be the data type that you're looking at. So if you're ever wondering what your data type is, you can use the type function for that. And then if you ever want to validate that the type that you're looking at is of a particular type, the data type of the object that you're looking at is of a particular type, then you can use the isInstance function. And this works well for basic data types, but like in the future, when we get to talking about classes and exceptions and things like that, we can use isInstance in those cases as well. But don't worry so much about that right now. Just keep in mind isInstance is super helpful in a lot of cases, because sometimes you may want to do one thing if you have one data type, or do another thing if you have another data type. Or in this particular case, say we do need it to be an int, we could check isInstance user input an int. If that returns false, then we could cast it to an int. So just keep in mind isInstance is super useful in that sense. And then type, also useful for making sure that the type is the type you're expecting, or if you're getting some weird behavior from your code, you can do type to find out maybe why that is. Say you're like trying to do certain operations on a variable, and you think it should work based on the data type you think that variable is, but it's not working. Check the type of your variable. It's possible that it's not the data type you're expecting. Any questions on this slide for isInstance, type, or the user input? All right, great. So now getting a little more complicated here, we can accept input via files as well. So input can also be read from files using the open function. The open function takes two parameters, the file name or basically file path, and a mode. So the file name is the path of the file in the system along with the file name and its extension. So this is something important to note here, is that it's the full path to the file, and it's the full path to the file from your computer's root, not from the directory that you're working in. So you have to build out your computer's root directory, and I'm going to show you a little tactic for just adding in the path to your current working directory during the demo at the end of the class. But just keep in mind that you need the full path to the file. You can't just do the relative path. And don't worry too much about exact path versus relative path. That's something we'll cover later on, but just keep in mind that here we need the true path of the file. And then the mode is basically the mode you want your open operation to occur in. So there are four options. There's R, A, W, and X. So for R, this is for reading a file, and it returns an error if the file, I think this should say doesn't exist, because R is just for reading a file. So if it doesn't exist, we'll get an error, and this is the default. So if you don't pass the mode argument to the open function, then we'll get a read operation. And in a read operation, all you're able to do is read the file. You can't modify the file at all. But say we do want to modify the file, we can use the A argument as one of our options. The A argument is for appending the data into the file, and it creates the file if it doesn't exist. So if the file doesn't exist, then it'll be created, and the contents of the file will be preserved. So if we want to, say we have a file with a few lines, and we want to add a line to it, append is the way to go, because it'll preserve the contents of the file, and anything we input to the file will just be appended to the end of the file. But conversely, say we want to overwrite the contents of the file, then we can use the W mode. And this stands for writing. So it's for writing into the file, and it creates the file if it doesn't exist. So keep in mind though, using the W argument, it'll overwrite anything within the file. So if you use W and there are lines in the file already, then you're going to end up basically deleting all the contents of the file, and then whatever you input to that file will be the only thing within that file after using the W argument. If you want to maintain what's in the file and only add new stuff to it, use the A argument or the A mode. If you want to overwrite the file and delete everything that's in the file and only add your new input into that file, so that you only have the new input you're adding, use the W argument for mode. And then there's also X. We can use X for creating a file, and it'll return an error if the file exists. So this is a good way basically to try just creating a file, not doing anything with it. But if you want to create the file, then you might end up, sorry, one moment. Okay. If you want to create the file or make sure the file exists, one thing you could do is with the X mode. There's other better ways though for making sure the file exists, because this one will raise an error if the file exists, and then there are other ones that just return true or false. Let me check one thing. Okay. All right. So we're going to see some examples of this in a moment, but do you have any questions on this before I go on to the next slide?
Hello.
Hi.
I have a question. Hello, David.
Hey.
My question is, for instance, if you have a file existing and you want to remove some part of that file, what are you going to do? Are you going to be using A for the append? But will it work if you use A? If like I have some content of my files that I want to remove. I don't want to wipe. I don't want to use W to rewrite the whole document. I want just to remove some parts of the document. What am I going to do?
Yeah.
What mode am I going to do?
Yeah, great question. So in that case, if you just want to modify some aspects of your file, you can use a combination of read and then write, where you could like read the file, read all the contents of it, and then make your modification to those contents, and then do another write operation where it would overwrite everything in the file, but you've already read in that file, made your modifications to the contents of that file, and then you write that back out, and that'll basically overwrite what was in the file with your modifications. And we'll see an example of that later on in the slide. Great question.
Okay. All right. Thank you.
Yep. Any other questions? Awesome. All right. On to the next slide. So input via files, the syntax. So open is generally preceded with the with keyword to handle file operations easily. And then you can use read lines. This function creates a list of each line in the file. And then there's read, and this this is a method. Read lines and reads are methods. They're methods on file objects. Open is a function. So open is generally preceded with the with keyword to handle file operations easily, because otherwise, if you open a file, you have to later remember to close it. But if you precede it with, then with will take care of closing the file for you. And this happens with a number of other things that can be opened and closed. But just for now, just know that if you precede it with, you never have to remember to close your file, because as soon as you exit the with, it'll close your file for you. Then the read lines function is, or method, it's a method called on a file object. And this method creates a list of each line in the file. And then read is another method, and this will read the entire file and return the text in a single variable. Instead of in a list, it would return like a text blob is what is one way you can kind of refer to it. So it's not read is not necessarily a good choice if the file is huge. For a number of reasons, you don't necessarily want an object that's or a variable that's really massive, and oftentimes you want to go line by line through something. So read, basically just make sure you're using these methods when they're most useful. Consider whether or not it's most useful to do read lines or read. Like if you need to iterate over the lines, using read lines is better, because that'll return a list of lines. And then since lists are iterable objects, as we talked about last week, then you can iterate over those individual lines. But say for Iffy's question, if we want to read the entire contents of the file, just make a quick modification to that, we can use the read function. So here's the code example we have. So we have our with keyword. So we're saying with open our file name. So it's like the path to the file. And then the mode, here we're just saying read mode as file object. So we have to name our file object. So this is saying with open this file as file object. So now that's the name of the file that we're going to reference inside of our with function. And we can do lines equals file object dot read lines. So remember, read lines, it's a method that we call on the file object using dot notation. That'll return a list of the lines in the file. And then when we print that out, we can see here, I am the input file line 1, I am the input file line 2. And this \n here, this is actually a new line character. So anytime you do read lines, you should expect, the ones at the beginning of your list, everything except maybe the last line will have a \n at the end, because that \n stands for a new line. And since you're doing read lines, it'll return each line in a different element of your list. So just go over this once again. We have with open our file name, and then the mode that we want to open it in. We're reading this in read mode, as we saw from the previous slide. And we're opening that file as this file object. So this is our reference to the file object. And it's basically the object name to access the file. And then within our with statement, that's where we're gonna actually play with our file object or do operations on our file object. So then we take our lines, file object dot read lines, store that in lines. We exit our with by coming out of the tabbed in aspect of being within the with. That coming out of there automatically closes our file there. and then we can print the lines, and we see our list of lines here. Any questions on these, on open, read lines, or read? All right, cool. So for input via files, write and append mode. So append mode will add the text into an existing file and won't overwrite anything. It can be used on an empty file as well. So write mode will add the text into an existing file and erase everything which was there before. So this is, I love this slide. This one's so perfect. In this particular case, here's our file. We have example.txt. We have I am the input file line 1, I am the input file line 2, and then a blank line here. Then in this particular case, we're using append mode on the left hand side here. We're using append mode. So we have with open example.txt. Remember, we do our file name there, and then we have our mode that we're specifying here. We're doing A for append mode, and then as the file object. And then we reference that file object within our with, and then we're writing, we're calling the write method on our file object. So we're writing to that file. And this is then the line that we want to add into our file. I am the new line with a new line at the end. And then that adds a new line to the end of the file. And then this is the resulting file here. We see our original input is still there because we used append mode. And now we see that I am the new line existing in that file. So then still using that same original file, if we instead use write mode, so same file, example.txt, and we have our write mode W here as file object, then we do our file object.write, I am the new line. Because we opened it in write mode, everything within our file was overwritten. We have nothing in our file now except for that I am the new line. So this is a great way to visualize the difference between append and write. So if you want to preserve the existing contents of your file, use append. If you want to overwrite everything in your file, use write mode. Any questions on this slide? All right, great. So files and folders. Sometimes it's required to read and write into multiple files that are present in a directory or subdirectories. With our current knowledge that we've gone up to so far, we will write the path of every file and perform the operation for each of them. What to do in case there are hundreds of folders and thousands of files inside of them? Well, Python provides an easy way to iterate the folders and subfolders in a path using the library OS. We need to import the library before using these functions. So this is one of those things that it's not necessarily built in, but it does come with all installations of Python. So at the beginning of your file, you'd want to do import OS, and then you'll have access to the OS package within your file. And we'll talk more about packages in the future. Just right now, OS is an important one to know about. And recall back to our arrays week, we were also using the array package for referencing our array objects. Cool. So the OS function the OS package has a walk function within it. So to iterate all the files and folders in a directory, including subdirectory and subfolders, use os.walk. So this is how we can walk over a directory. This is like basically iterating over all of the files in that directory. So when you call walk, it returns a tuple object. It returns an iterable of tuple objects, and one of the first value in that tuple is the root folder. The second value is all the folders within the current root folder, and then the third thing in that tuple is all the files within that root folder. So in this particular case, so recall back to our for loops, we're saying for root folder files in os.walk, and then this is our root folder that we're walking over. And then we're going to print out the root, we're going to print the folders, and we're going to print the files. So our root path right now is root folder. So we have that root path, and then on our first iteration of the loop, we see that as the same output as we put here, because our first iteration of the loop, we're at the outermost or the top directory, basically the root directory. You'll hear root directory pretty often, or root folder in computer science pretty often, because root is basically like, you know, the broadest directory in a set of directories. So here we have our root path. So it's the same root path that we put in here is the root path that's output on our first iteration of the loop. Then these are all the folders within our root path, because that's the second thing we're outputting. So all the folders within our root path are folder 1, folder 2, and folder 3. And then there are no files in our root path, so we just get an empty list here. And this all up here is the first iteration of our loop. On the second iteration of our loop, the root path is now going to be root folder folder 1, because we're basically diving in to our next directory. So now our root path for this iteration of the loop is going to be root folder folder 1. And then within that, we the folders that we have within folder 1 are subfolder 1a, and then and that's the only folder we have within folder 1. And then we have a file within folder 1, and that's file 1a.txt. Now our next iteration of the loop, we dive even deeper. So now we're going to go into that subfolder 1a. So now our root path is root folder folder 1 subfolder 1a. There are no folders within that that subdirectory, but there are two files in here. So we have file s1a.txt and file s1b.txt. So these are all the files within subfolder 1a. Since we now don't have any more directories to dive down into, we're going to kind of pop back up to here. We're going to go to folder 2. So one way to think of it is, here, do we have any folders to dive into? No. Come up here. Do we have any more folders to dive into? Because remember, we just dove into subfolder 1a. Do we have any more to dive into? No. So come up here. Now we want to dive into folder 2 of this broader path. So then in here, you know, we have our root is now root folder folder 2 on this iteration of the loop. And we have within here, we have 3 subfolders, subfolder 2a, 2b, and 2c. And then there are no files within folder 2, basically. Now we dive into subfolder 2a. Subfolder 2a is now our root in this iteration of the loop. No folders, no files in there. So now we go to subfolder 2b. No folders in there, but there are files. We have file s2a.txt and file s2b.txt. And since we don't have any more directories to dive into there, we come back up here. Now we want to go to subfolder 2c. In subfolder 2c, there are no folders, no files. Now that we're done iterating everything within folder 2, we come back up and we want to iterate folder 3 now. So we go into folder 3, no folders, no files. So this definitely takes some time to get used to working with the root with os.walk. But once you get some hands-on experience with it, it's a hard thing to forget, and it's pretty intuitive once you do get some hands-on experience with it. It is just complicated when going into it. Just keep in mind, whenever you do an os.walk, there are 3 things returned by each invocation of. So there are 3 things returned in each iteration of os.walk. So on the first iteration, so os.walk is an iterable. It returns an iterable. The first thing returned is a tuple of root folders and files, and then we can access those root folders and files here. This next iteration, we kind of dive into the first folder in the root folder if there is a folder there. So I know this is quite complicated. We're definitely getting to the point in the class where everything's starting to accelerate. Any questions on this? All right. So continuing with OS, to check if a path exists or not with OS, use os.pathExists. And over here, we have an example of that. So here, see, we had to import OS, and then we've defined the path here. And in here, so for Windows users, you'll be familiar with why we've been seeing this C:/ and all that stuff. That's just how Windows works. It looks different in a Mac. Just something to keep in mind, that your file paths might be different from Mac to Windows or Linux. So just keep that in mind. If you have any questions on it, do let me know. I can help with that. But here we define a path as our C drive random path. And then if os.path exists, so this will return true or false. If it exists, it'll return true, and then we'd output directory path is correct. If it's false, if the path doesn't exist, this returns false. We don't go into this part here. We come to the else block, and then it says incorrect directory. So in this particular case, we don't have a path or a directory random path, so we get incorrect directory in this particular case. So so that path doesn't exist. To check if a path is to a file, not to a directory, we can use the os.path.isFile, and we'll see that down here in a moment. To check if a file is empty with OS, use os.path.getSize. So when you call getSize, it'll return the size of the object or of that file. If it's 0, then we know the file is empty. If it's not 0, there must be something in the file. And then we can see the below example where we first checked if a file is available in the path, and then check the size to avoid Python exceptions. So in this particular case, we're importing OS. We have file path R, and there will be a little thing popping up here in a second that'll explain that R, but I just want to review this first. So we have path R, and then our C drive, /root folder, /folder1, /file1a.txt. In Windows, you'll often want to use backslashes. In Mac, you'll want to use a /. Just keep that in mind. You might run into that. You probably will run into that in your assignment. So just try to keep that in mind. If you're getting any errors, that might be what your issue is. So here we're checking if os.path.isFile file path and os.path.getSize file path is greater than 0. So first we're checking, is it a file? Is this actually a file? If the file exists, or it's not a real file path, or say we were just going to directory, this would return false. But in this case, it's going to return true, because let's just assume this path to this file does exist. And then os.path.getSize returns the size of this file object here. If there's anything in the file, this will return some number greater than 0. If there's nothing in the file, then it returns 0. So we're checking, is your file empty? Because we're checking if it's greater than 0. If it's greater than 0, then the file is not empty. If it is 0, then the file is empty. So this order matters here as well. So order is important here because we first have to check, does the file exist? And if we check, and if this returns true, then this part will be evaluated. If this returns false, then it's not a file, and we can't call the getSize operation on that file. So this order is important. That's what is meant here by we first check if a file is available in the path, and then check the size to avoid Python exceptions. So if we try to check the size on something that doesn't exist, we're going to get an error. But in this case, we first check, is it a file? If that's the case, then we're going to check the size of the file, and then assuming both of these evaluate to true, because this is an AND statement, then we print the file is not empty. If one of these evaluates to false, so either it's not a file or its size is 0, then we come to this else block here, and we're going to print either file path is invalid or the file is empty. And then in here, just to see whether or not the file path is valid, then we're going to check again if os.path.isFile, then we say file path is valid and file is empty. We know the file is empty because if this evaluates to true here, it also would have evaluated to true up here. And then that must mean this part was the part that evaluated to false. And that's why we didn't end up in this block and instead ended up in the else block. So running this, in this case, we get either file path is invalid or file is empty. So this gives this path either isn't a valid path or it's an empty file. And so then we check, is it an empty file or is it a file? This returns true in this particular case. So it says file path is valid and file is empty. So we know the file is empty because this must have evaluated true, but then this part false. So that's why we ended up in the else block. And then we get both of those outputs there. So something important to note here, see how we're using the R in the file path. R is used to include a backslash in the string. So if you ever need to include a backslash as an actual backslash in your string, use the R in front of it because that'll allow the backslash there. Otherwise, backslash in strings is used for an escape because there are a number of things in Python that are considered special characters. So like, that backslash n that we talked about earlier, that creates a new line. But say for some reason you wanted in your file, you literally wanted the string backslash n, and you don't want it to create a new line in your file, you have to escape that backslash n using another backslash. So I'll show an example of that later on. Just for now, if you ever need to use a backslash in your string and you want it to be evaluated as a real backslash, use the R. If you want it to be evaluated as a special character, like doing backslash n for a new line, don't use the R, just have your backslash n, it'll create a new line. Cool. Any questions on this slide? All right. So kind of going back to Iffy's question earlier today. So files and folders for replace. What if we need to replace a string with another and create a new file? Use the replace function. So open can be used in a single line using with to loop and read and write at the same time. So we can call open multiple times in a single if or in a single with on multiple files. So in this particular case, we have example.txt. I am line 1 with incorrect spelling of Python, and so we didn't spell Python correctly there. I am line 2 with same mistake in spelling of Python, but this time in the middle of the line. So we want it to say Python, right? We put in a typo. We want to fix this programmatically. We don't want to do it. We don't want to have to open up our file and manually type this. So what we can do here is we can use our with open, and we're going to open 2 files here. The first file we're going to open is our example.txt file, which is this one up here with our spelling mistake. We're going to open that in read mode as file input object. And we're also going to open our correct example.txt file in write mode as file output object. We need them to have different names here because we need to reference them separately. If they have the same name, Python won't know which one we're trying to reference. Really, what's going to happen is the second iteration is going to overwrite the first invocation. So we'd basically actually be just looking at correct example.txt if we gave them the same name of just file object. Just keep in mind, whenever you do this, you want to do you want to make sure that the as part has different names. So then within our with, we're going to iterate over each line in our file input object. So we're doing for line in file input object, correct line equals line.replace. So we're using the replace function. Replace it's a method that you can call on a string. So we call replace on our string line using dot notation, and we're replacing Python with Python. So the first thing you put in is what you want replaced. The second thing you put in is what you want to replace it with. So now we use our file output object. So we've corrected the line here by replacing Python with Python. So now we want to write that to our file output object. So we take our file output object, we call our write method on that file output object using dot notation, and we write our correct line to that file. And then once this is done iterating, we now have the correct example where it says, I am the line 1 with incorrect spelling of Python. It's no longer incorrect because we corrected it here in our code. And then I am line 2 with the same mistake in spelling of Python, but this time in the middle. So the point here is to recognize that it'll find the instance of whatever you're trying to replace anywhere in your line. It doesn't have to be at the end. It doesn't have to be at the beginning or in the middle. It can be anywhere in your line, and it'll find it and replace it. So it's kind of like, in Word, if you ever have to do the find and replace operation or any text editor, that's what this line of code is basically doing for us. Any questions on this? And this kind of goes back to what Iffy was asking earlier. How do you correct a mistake in a file? Well, you open that file in read mode, and then you open another file in write mode, and then you read the file that has the mistake, and then you write, and then you make the updates in there and write to the file to a new file that wouldn't have the mistake. So any questions on this? All right. So additional resources here. We have tutorials point here for different modes of accessing the file and different functions in the OS module. Highly recommend looking at it. OS is extremely useful. You'll use it all the time throughout coding in Python. We'll talk more about packages in the future in a future lecture, but OS is super useful. So read up on it. Highly recommend it. The split function. So split function, you're going to need this for your assignment. I don't really want to go over it here. Well, I talked about it last week. I briefly talked about how to use split last week. And basically what split does is it takes a string and splits it into a list. I don't want to go too in depth here about the split function, because something that you'll all need to get used to for getting a job in programming is reading documentation and trying to understand what the documentation tells you about the function. So check this out to get an idea of how to use the split function. You'll probably need to use it for completing the assignment. You might be able to find a way around using it, but I highly recommend looking into the split function and how to use it. And if you have any questions on it, let me know. But again, I want to leave this as something that you all go and read up on your own, because you'll need to get used to, someone not explaining everything to you, and instead you'll have to go, do your own research, read the documentation. Documentation, it's not fun to read typically, but it's one of the best ways to learn a new package is to just, or a new function or a new method, is just to read the documentation. Yeah, and then some practice exercises for file operations. You can find those here. So highly recommend doing those before the assignment. It's going to help a lot with understanding how to do those the assignment. Let me check the chat. Awesome. Okay, any questions on the PowerPoint today or any of the slides that we covered that I can talk about now before going on to review the assignment? I know it was a lot today. All right, so hopefully the silence is because you're all understanding it, and not because you're confused. Any questions? Okay, yeah, okay, so we're definitely ramping up in class now. You probably noticed that loops are pretty hard to wrap your head around. IO operations are again going to be hard to wrap your head around. Everything from here on out, like what we've learned so far has been the basics, the very basics of Python. And now we're getting into stuff that's a little more advanced. So things are going to continue to increase in complexity. So just a heads up, it's expected. If you have any difficulties, just feel free to ask questions. I highly, highly, highly recommend at this point now, if you have a question, please ask it on the YouTube lecture video, because then anybody else can come in and look at that same question. I can answer it in one place, and then everybody can see that same answer, and even future students will be able to see those answers. So strongly recommend, if you feel comfortable, please ask the question on the PowerPoint or on the YouTube lecture video, because then it's kind of preserved forever and everybody can reference that same thing. You're probably going to need to rewatch this lecture because this is some pretty complicated stuff. It might seem somewhat straightforward when we went over it because there are all these like streamlined examples in here, but this stuff is complicated. Don't get discouraged if you're having a hard time with it. That's expected. Just feel free to reach out or post questions to the YouTube video. All right, so last chance for questions on the slide deck. All right. Okay, so the assignment this week, it's It's definitely going to challenge you, just a heads up. So for a week 7 assignment, the background is there's a folder named college that I'll be providing to you. I'll be sharing it through Google Drive. You'll just have to download it and go from there. So the folder has many subfolders, and these folders may or may not have files inside of them. The folders inside college have the name stream 1, stream 2, and stream 3, and I'll show you this in a second. We'll actually go over the folder structure. These folders have files named as studentdetails.txt and facultydetails.txt, which have information for students and faculty respectively, given as their ID, their enroll year, their name, and there might be some other details in there. So note, even if the folder has a file inside of it, the file may be empty. So keep that in mind. Remember the methods that I talked about in the lecture earlier today. You will want to leverage those. So for question 1, write a program that accepts a file name as user input and create a file inside the college folder if the user writes a valid file name. So as long as a valid file name is given, create that file. Otherwise, print invalid file name in the console and exit out of the program. Hint, user can press enter instead of writing a file name, and this is a failure condition. So if you're trying to test your failure condition, just don't enter anything to the user input there. Have the user input ask you for something, just hit enter. Hitting enter will just basically pass nothing. That'll be a failure condition. Make sure you're capturing that failure condition. Another thing to know is that if you want your code to exit when a certain condition is met, like say they enter an invalid file name, then we can use the exit function here. Passing a 0 means that it'll exit with exit code 0, something you've definitely seen because it's in our slides. Oftentimes, let me find an example. Process finished with exit code 0. That means it finished successfully. Exit code 0 is a success response. Anything other than that is not a successful response. So if you want your program to exit successfully without generating errors, do exit 0, and it'll terminate the execution of your code. So a couple hints here for question 1. So question 2, modify the program in question 1 to write a header inside the file if the user enters a file name or a valid name. So headers are basically like columns. So thinking about Excel here, in Excel you typically give column names for your for each column in your Excel document. In this case, we want to have our column names basically be ID, enroll year, name, stream, student, faculty, source file path. So this is how we want our header. Basically what you're generating here is what's called a CSV file. A comma separated values is what that stands for. So you can see there's a comma here separating our values. And there's a lot of things in computer science in general that facilitate reading CSV files. But hint, this is kind of where your split is going to come in when you're reading the files, just so you know. Question 3, write a program to iterate through all the folders inside the college folder and read the data from the files and write inside the file created in question 2. So in here, in question 2, we've modified the program in question 1 to write a header inside the file when the user enters a valid name. So basically here, we first enter a valid file name. So say like output.txt. And then this should go ahead so then in question 2, we actually create that file and we add this header into the file. And then for question 3, we're going to take that file and we're going to modify it so that we iterate over all of the folders in the college folder. And we're going to read the data from the files and write inside the file created in question 2. So we're going to write inside of in the example that I'm kind of going through here, output.txt. So tip, ID, enroll year, and name is given in the source file. So you'll want to get it from the source file. And then so these 3 values you can get from the source file. The stream is the name of the subfolder. So we'll see this in a second when we go over the subfolder names. So basically you want to use the subfolder name. And remember, within here, as mentioned up here, the folders inside college has names as stream 1, stream 2, and stream 3. So we basically, if the ID and roll year and name came from stream 1, we want to put stream 1 as the value for stream. Student, if the data is inside the student details file, then write yes for student and no for faculty. And you can just use N and Y for that there if you want. Then for faculty, just like with student, if the file name from where the data is read from is the faculty details.txt file, then write no for student and yes for faculty. So in this example here, okay, and then let me just go over this last one here. So source path is the full path of the file from where the data is being read. So you want to make sure that you append the path of the file that's being read from. So expected format of the output. So in here, we read one, so ID 1, they enrolled in 1875. Their name is faculty 1. They came from stream 1. Are they a student? No, their name's faculty 1, so I sure hope not. That would be kind of confusing. Are they a student? No. Are they a faculty? Yes. And then their source file path is this file path here. So you may need to learn about the split function in Python to get this to work. So just to look at the folder structure here. So I'm going to be sharing this particular folder with you here. So here's the college folder. We go into that. We have stream 1, stream 2, and stream 3. So if we go into stream 1, we have a faculty details and a student details file. And then if we go into stream 2, we have subfolders now. So we're going to have to iterate into these subfolders. Nothing in this subfolder. There are faculty details and student details in this folder. And then nothing in this subfolder here. So now we come up again here, and then we also want to iterate into stream 3. Stream 3 has faculty details and student details.txt as well. Notice here, faculty details is an empty file, but you want to make sure that your code can recognize this dynamically. Don't hard code how to handle this specific case. What I want is basically that I can come in and I can create any directory structure that has college, stream 1, stream 2, stream 3, stream up to 100, maybe. Say I want hundreds of streams, and I want you to still be able to iterate. I want your program to still be able to iterate over however many stream folders I put in here. And then, this one has some subdirectories, but say I even have further subdirectories down here, your program should be able to handle that. Yeah. Any questions on the assignment? All right. So I just want to reiterate here that we are getting into some some fairly complex topics here. This is no longer just the most basic programming. Now you're getting into a little bit more complicated stuff. So we're not just talking about data types here and basic variables and operations on those variables. Now we're getting into built-in functions and things like that. So excuse me, this will be difficult. I want to be very transparent about that up front. Everything's gonna, really ramp up now. This assignment will be a challenge. Please don't get discouraged. And then let me know if you have any questions. This college folder will contain the expected output. So you can kind of see what's expected here. Your paths here might be different. So Gaurav has a Windows machine, so he has the backslashes in his file path. For me, I have a Mac, so I would have forward slashes in my file path. Either one's totally fine. I'm not going to be validating that you have the exact same output here. This is just, I just wanted to call that out. I just want to make sure that you have basically the general structure here, that we have a path to a file in the last thing here. Yeah, and it should be output in CSV format, just like this with the comma separated values. Yeah, let me just download this because I just want to show you that when you use a CSV, Excel actually does this is a .txt file. So if we save it as a .csv file, we could open it with Excel, and it'll actually open in the columnar format that we would expect. So I just want to show you that real fast. So just to kind of show here, I have this file here. I'm going to change it to a CSV. Use CSV. Now I can open this in Excel, and it's actually going to show up in with the column separated values in like a expected columnar format, which is pretty cool. That's one of the reasons why we wanted output in a CSV file. It makes it much more readable. Oops. See, so here, now that I've opened the CSV in an Excel file, we can see that, you know, we have our column, our headers, ID, enroll year, name, stream, student, faculty, source path, and everything matching up perfectly there. Cool. Any questions on the assignment or material that we covered today before I stop the recording to go over what was expected of the assignment last week? All right. Sounds good. Well, thank you everyone for joining today that was able to join. It was great to see so many people join. Yeah, feel free to reach out if you have any questions via email. Again, highly recommend that you go ahead and comment your questions on the PowerPoint, or sorry, on the lecture that I upload to YouTube, because this stuff is complicated. I know people have more questions than they wanted to ask during the slides today because this stuff is complicated. I know there are going to be a number of questions. Please comment your questions on the PowerPoint or on the lecture. It'll help other students who maybe feel a little more shy about asking questions. And it helps me make sure that I you know, if I miss something in the lecture, if everyone's asking the same question or found the same question valuable, that means I probably should have covered it in the lecture. So you're helping me a lot by asking these questions there, or asking questions in general. But you're helping your classmates even more when you comment them on the lecture, on the lecture video on YouTube. All right, so thank you everybody for joining today. I'm going to go ahead and stop the recording so that we can review the assignment from last week.